Today we're going to look at three-dimensional figures and talk about how to name and describe them. And before we go further, we need to understand what a three-dimensional figure is. We've been talking about two-dimensional figures. Those are figures that you can measure a length and a width, that sort of thing. But when you talk about three-dimensional, you can measure three dimensions, a length, a width, and a height, for example. And when we talk about naming them, one of the words I want you to know is polyhedron. A polyhedron is a 3D or three-dimensional figure that is made up of faces that are all polygons. Now, can we have three-dimensional figures that are not polyhedrons? Certainly. You can have things like a sphere or a cylinder or a cone, something like that. And those are three-dimensional figures, but they're not polyhedrons because they have curves. A polyhedron has to have faces that are all polygons. Now, speaking of faces, faces are the flat surfaces of a three-dimensional figure. So they're the surfaces that you could lay a hand against. An edge is the intersection of faces on a three-dimensional figure, and a vertex is the point where the edges of a 3D figure meet. So we'll look at that a little bit more here in just a minute. And then the base would be, it is a face, but specifically it's the face that we use to name a three-dimensional figure. And lateral faces are also faces, but they're the faces of a prism or a pyramid, which are not the base. So in other words, every prism or pyramid is made up of faces, and those faces are either a base or a lateral face. So prisms and pyramids, those are some words that I mentioned that you may not know. So let's talk about that just a little bit. The difference between prisms and pyramids. The green one that you see here is a prism, and the blue one is a pyramid. And you probably already knew that word pyramid if you think about Egypt and the Great Pyramids. Probably you knew that one on the right was a pyramid. And let's talk about that one for just a minute. The reason that it is a pyramid is because it has triangular faces. Most of its faces are going to be triangles, all but one in fact, and sometimes even that one is. It has one base, and that's what we use to name it. So the one that you see there on the right, for example, is a rectangular pyramid. It's a pyramid because most of its faces are triangles. It's a rectangular pyramid because its base is a rectangle. Now, I would like to point out, a lot of people like to when they're asked to name it, they like to say rectangular pyramid. They like to come up with that first word first, but it's easier to come up with the second word and identify it as a pyramid first and then tell what kind it is by looking at its base. A prism is different from a pyramid because a prism has mostly rectangular faces, and it has two bases instead of just one, two parallel and congruent bases. And the prisms are going to be named by their bases. So this prism, for example, is a pentagonal prism. It is a prism because 5 of its faces are rectangles, and then the other 2 faces, which are the bases, are going to be your pentagons, and that's why it's a pentagonal prism. I would like to point out that on the rectangle, on the pentagonal prism rather, the rectangles are lateral faces and the pentagons are the bases. On the pyramid, on the rectangular pyramid, the triangles are the lateral faces and the rectangle is the base. So the base is the face that's used to name them. The other faces are lateral faces. So let's look at some examples here and see if you can name these figures. And I did put some in here that were not polyhedrons, and that's okay. Let's see if you know those names anyway. So if I were to start, I'm going to do the first few with you, and then I'll let you try some. I'll do a few with you. So the first one you should look at and you know is a sphere. That's probably a word you have heard before. The one underneath of that, if you look at it very carefully, most of its faces are going to be rectangles, and its base is going to be a triangle. Now, some of you might have a hard time with this figure seeming like it moves on you. If you have that issue, try coloring in the face that it appears to be sitting on, and that may make it sit still better for you so that you can identify it better. That one is a triangular prism. It's a prism because most of its faces are rectangles rather, and it's a triangular prism because its bases are triangles. So that is a triangular prism. The one below it is a triangular pyramid. It's a pyramid because most of its faces are triangles. It's specifically a triangular pyramid because its base is also a triangle. Let's take a look, and I want you to try to do the rest of them and then take a look at the answers. All right, looking at your answers, take a minute again to notice. We have some figures that are not polyhedrons. So the sphere, the cone, and the cylinder are not polyhedrons because they have faces that are not polygons. They have some curves in them. And then if we look at the rest of them, all of the rest of these are either prisms or pyramids. Number 4 is a prism. Even though it's not labeled prism, it is a rectangular prism. It has a special name of cube because all of its faces are congruent squares. We have the hexagonal prism, a pentagonal prism, a rectangular prism, and a triangular prism all represented here. Notice what all of those look like. They have two bases. Their lateral faces are rectangles. And then take a look at the prisms, rather, the pyramids rather. For the pyramids, we have a triangular pyramid, we have a hexagonal pyramid, we have a pentagonal pyramid, and we have a rectangular pyramid. Notice for each of the pyramids, they're going to be named by one base. They have just one base, and opposite of that base is where the pointy part is, so to speak. And they are, again, named by their base, and their lateral faces are going to be triangles. Now let's talk a minute about faces, edges, and vertices. Remember that a face is the flat surface of the figure, is one of the flat surfaces of the figure. So let's look at the cube to begin with. The cube has 6 faces because it's made up of 6 surfaces that are each squares. Then when we think about vertices, we need to think, or we think about edges rather, the edges we can draw in here. I want you to imagine that if you were putting this together, putting a cube together made out of toothpicks and marshmallows, the toothpicks would be the edges. So here, these are 4 edges, 5, 6, 7, 8 edges, 9, 10, 11, and 12. Again, counting and drawing on the figure is going to help you. So that one has 12 edges. And then when we think about vertices, again, think about putting this together out of toothpicks and marshmallows. Where would you have to have a marshmallow? You would need one here, 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 here. That makes 4, 5, 6, 7, and 8. So the cube has 6 faces, 8 edges, or 12 edges rather, and 8 vertices. Let's look at one of our pyramids. Let's look at a pentagonal pyramid, for example. Notice that for our pentagon, we're going to have 6 faces. We're going to have 1 pentagonal face, and we're going to have 5 triangular faces. The pentagon is our base, and the triangles are our lateral faces. As we count edges, count along the base first. 1, 2, 3, 4, 5 edges that are along the base, 6, 7, 8, 9, 10 along the sides of the triangle. So 10 edges. So there are 6 faces rather, 10 edges, and then when I look at the vertices, I'm going to have 1, 2, 3, 4, 5 here around the base, and a 6th one up here. So our pentagonal pyramid has 6 faces, 6 vertices, and 10 edges. Now, another thing we need to know about three-dimensional figures is we need to know if we unfolded them. Think about this like unfolding a box, for example. If we unfolded them, what would they look like? So, for example, if I wanted to know what a hexagonal prism would look like, well, let's think about what we know. We know from the word prism that most of the faces have to be rectangles, and we know from the word hexagonal that the bases are going to be hexagon. So if I started with a hexagon, for example, I know that that's going to be my base, and coming out of each hexagon, I'm going to need to have a rectangular face. So I could do something like this, and like this. Here's gonna be one. I'm going to need 6 of those, in fact. So I could put one here. could put one down here, and I'm going to put one here. Let's rotate that a little bit to go right there. And I'm going to need a fifth one. And one more to complete all of the rectangles that I'm going to need. Oops, let's see. All right, so that's going to give me my 6 rectangular faces, and I need 6 of them because my base has 6 sides. I need one rectangle coming from each side. Now I want you to imagine folding along the edge between the hexagons and each of the rectangles, and you should be able to think about folding those up, and when I fold them, this edge, for example, is going to close with this edge. This edge is going to close with this edge, so forth and so on. And then I'm going to need, once it's all closed up, I'm going to need one more hexagon, and I'm going to need that hexagon to close the whole thing. So notice if I put one here, then once I folded everything up, I would be able to fold that hexagon and close the figure, and I would have a closed three-dimensional figure. All right, and we could do a triangular pyramid. Pyramid means most of the faces are going to be triangles, and the fact that it's a triangular pyramid means, in fact, that all of the faces will be triangles. So we're going to have something that looks a little bit like this. Let's see. Could close it like that. Like this. And then our last one could go right here. And we would have then a closed triangular figure. A closed figure where all the sides rather are triangles. And so that's the idea of what a net is. And we could make a net for any figure. It really just means that we need to look at it and decide what shape are most of our faces, and then how could we arrange them so that if we folded it up, they would all fold together to make the three-dimensional figure that we want to make.